Okay, so we have two lines with symmetric equations. And we need to write the general equation of the plane containing line 1 and line 2. So this is line 1 and this is line 2. And so you see here we have our symmetric equations of the line. And then here is our equation of the plane. So we need to find two things. We need a point right here, and we need our normal vector, which is right here. So let's start with line 1. And it is in this format. X plus 3 over 2 equals y over 6 equals z over 3. So you can see here A, B, and C. So that is going to be in a vector on the plane. 2, 6, and 3. So you can tell what format it's in. So now we need to find the point. And if you remember, it's x minus x0, y minus y0, and z minus z0. So because this is x plus 3, it means it would have been a negative 3 for the point. And then y has 0 and z has 0. So it's just going to be 0, 0. So that's one of the points on the plane. So now let's look at L2. L2 has x minus 1 over negative 1 equals y plus 6 of negative 9, z plus 1 of negative 1. So another vector on the plane there is negative 1, negative 9, negative 1. And we're going to have a point 1, negative 6, negative 1. So I'm probably going to use this point in my equation because it's easier. It has 2 zeros. But we still need to find our normal vector. And if you recall, our normal vector is perpendicular to the plane. So we have our plane right here, and we have our vector going up, and that is our normal vector. So what we need to do is take the cross product of u and v to find this normal vector. So let's do that real quick. All right, we have 2, 6, 3. That's I, j, and k. And we have negative 1, and negative 9, and negative 1. And so I just like to do this. You hide one row, and then we'll do 6, 3, negative 9, 1. That's minus j hat. 2, 3, negative 1, and plus k hat. It's 2, 6, negative 1, negative 9. And if you recall, when you take the cross product, you multiply diagonal and then subtract and multiply the other side. So let's go over here. This is running off the page, a little bit messy, but we have I negative 1 times 6 is negative 6 minus negative 9 times 3 is negative 27 minus, this is our j hat, and then negative 1 times 2 is negative 2 minus negative 1 times 3 is negative 3 plus k. So we have negative 9 times 2 is negative 18 minus 6 times -1 is -6. So -6 plus 27 is, that does not look like an I. So that's going to be negative, it's just going to be 21 minus j, so -2 plus 3 is a positive 1, but the negative distributes and it'll be just -1, which you could just leave it as negative j because we'll consider that as a 1. And then plus k hat, negative 18 plus 6, 6 times 3 is 18, so 6 plus 6, 12. So we're going to have negative 12. Okay, so now we have, this is going to be our normal vector. So our normal vector is going to equal 21, -1, and -12. So now you can go back in and plug it into this equation up here. So this is going to be A, B, and C. And you could take any point, but I would probably take the point that's the easiest, which is -3, 0, and 0. And so we can just do that right now. Just get to a new paper. So now that we found our normal vector, which is -21, -1, and -12, and we have our point that we found from one of our lines, which is -3, 0, 0. We can use this equation because this is going to be A, B, and C. This is going to be x naught, y naught, and z naught. And we have our equation A, x minus x naught, plus B, y minus y naught, plus C, z minus z naught equals 0. So now that we have that, we can go 21 x minus -3 plus -1 y minus 0, it's -12 t minus 0 equals, so 21x and 3 times 21 is plus 63 minus y, and then -1 times 0, 0, and then we have minus 12z equals 0. So we're going to have 21x minus y minus 12z plus 63 equals 0. And that is going to be our final answer for the equation of the plane containing those two lines.